I'll start with a very short statistics on our work for 12. I'll talk about VMI on AMD, a phenomenon, so to speak. I'll call it the Windows 10 RS4 event. The ongoing discussion about access and dirty bits updates, an emulation we're working on, statistics for HashV and VMFUNC, LP2M for the Citrix Hypervisor, and I'll talk a little bit about Intel SPP, subpage protection that became permission. So since my last talk in 2017, there have been 4 Zen releases, 68 patches for VMI alone, with the majority of them in 4.12 when we kind of pushed the pedal to the metal when Windows 10 RS4 came out. Colleagues of mine that worked on these patches. As you can see, Bitdefender is pretty committed to VMI. For me, at least, it's lately some kind of lifestyle. All right, I'll start with VMI on AMD. We enabled pretty much the common code for VMI. There wasn't a particular reason why it wouldn't work, or Zen Access events shouldn't work for AMD. They were just gated to Intel alone, merely because nobody tested for anything else. But since Epic came out, the interest spiked, so we started doing some enabling work for it. We hit 2-3 roadblocks that kind of temporarily put an end to that effort. So we have a case where we would like to mark certain entries in EPT, execute only. This is to offer some, to intercept some activity in the Windows kernel, patch code namely. And the NPT being page table-like, normal page table-like. There's no possibility to make an entry executable only, but not readable. The way we do VMI, we hook for write the guest page tables, the kernel, certain applications, everything. The problem on AMD is that when we do that, normal page table walks become write violations in NPT. So this will trigger a huge amount of VM exits and basically make VMI impossible to do real time. You can still do forensics, but real-time VMI is not possible at the moment. And another feature we did it is something that works like Intel Monitor Trap Flag, MTF. There are some debugging features in the AMD CPU that can probably be used in a creative way to do something similar. We haven't looked at it. As I said, the thing with the NPT triggering, behaving like EPT-AD essentially, is a no-go. So for the moment, we've put a stop on this project. We're looking to maybe talk with some AMD folks and see if there's something that can be done. But yeah. All right, so the Windows 10 RS4. As I said previously, we hook the guest page tables for write. We keep an evidence of everything that happens. Well, in RS4, Microsoft decided to alter their memory manager and use a bit in the page table entries for locking. As you can imagine, that increased the number of VM exits exponentially. We went through the roof. So it kind of ruined our parade. So what we did, we came up with, I'll call it a state secret, of injecting a little bit of code in the guest and do some pre-validation about what's going on in there. It works pretty well. From the start, we said, okay, it's a temporary solution. The proper way is just to leverage VE and be done with it. It works for 64-bit only by virtue of VE and VMFUNC. So while we were working on VE for Zen 4.12, we were writing this little patch wave. The access to dirty bits conundrum, there's a decent thread pretty long thread on ZenDevel. So what I've said in a previous presentation, that 90% of the page faults we get via EPT are of no interest for VMI-based security application. They are usually ADP to updates or some other management that it's not of interest. What we care about is permission changes, mapping, stuff like that. So what we wanted to do is in Zen, in the hypervisor, that 90% of faults, to treat it very rapidly and return to the guest. So those faults are access and dirty bits updates. So we proposed, an optimistic mechanism. So when an IPT violation arrives and it's generated by the CPU while doing the guest page table walk, if the access bit is unset, set it, return to the guest. If, however, it is set, then set the dirty bit if the page is writable and return to the guest again. In a test we did in-house, in our in-house hypervisor, it works pretty well. And we tested it with Zen as well, and it works pretty well. However, what we didn't manage to do is get some kind of confirmation that in future architectures, future generations of the CPUs, it will behave the same. So there was a little bit back and forth on the mailing list. We're waiting. We had some discussions with some Intel folk. Nobody said yes yet. Everybody's looking into it quite well. Ever since the whole speculation thing, everybody is a little bit uncertain about everything. All right. The other option is what happens now. Use the emulator to fully emulate instruction, let it do the page walk, let it do the bit updates according to whatever it's emulating. Or we can shorten the emulation path and just have it do null writes. Right? Never do the change, just have it do the page walk, do the updates, and then return to the guest. However, the emulator it's a beast. It has quite a decent overhead. And it needs to be kept up to date every time a new instruction set comes out. I appreciate Jan's effort in that direction, but it's still an effort that has to be constantly spent. The other option is single step via the monitor trap flag. It has a reasonable overhead. What we do is first try the emulator. If the emulator said, okay, the instruction is unknown, we do single stepping. Single stepping is pretty simple. Remove the protection, execute normally the instruction, place the protection back, and return to the guest. Anyways, no solution is yet in Zen mainline. There's a temporary solution in the Citrix Hypervisor, but we're so hoping that will be out of the patch queue.
The sooner I can get rid of that, the better.
Okay, a little bit. My last presentation in 2017, I presented some basic statistics we did in house. This is what Zen 4.12. Actually, no, it's 4.11 with the needed patches from 4.12 for V and Alt P2M. In blue is our little temporary hack that works pretty well, and in red it's the virtualized exception based solution. In certain scenarios it has a tiny bit of overhead, but it's still better. Security wise, it's the perfect thing. Things got a little bit out of hand with RS6, but it still has some ways until it finds itself in the market. Oh, Intel sub-page permission. Like V and VMFUNC, it's controlled via VMCS option. It uses a bit in the EPTE. It implements write protection only. It splits a page in 32 subpages, 128 bytes each. What we want to use it is to protect operating system structures that live in read-write areas of the kernel. For example, certain driver objects that are uninspiredly placed, that are seldom written, probably never, are mostly read-only, but placed in a page where there's something else that's being often written. So we plan to use SPP to protect a part of the page where the operating system structure of interest is found. We've done some internal tests for Windows, and we've determined that it's very good to protect certain driver objects, the interrupt dispatch table, HAL dispatch table, all pretty much everything core to the Windows kernel. Have I beaten my own record? Questions?
Wow, you're cutting off lightly here.
All right. I guess this is it for me. All right. Thank you very much.